What up? Nailed it. Just kidding. Mr. Regan here. Today we're going to look at practice with properties of exponents, zero exponents, and negative exponents. Treat this video more like a practice video. So you're going to pause the video when I bring the problems up, then play the video and watch me do it. See if what I do matches what you did. Alright, so if you're going to do that, pause it now. Alright, so number one, when I'm multiplying and I have the same base, which I do, my bases are x, then the base stays, and I add the exponents, 7, 2, and when there's no exponent there, we know there's always a 1. 7 plus 2 plus 1 is 10, x to the 10th power. Same thing here. I have the same base of 2. I'm adding my exponents, negative 3 plus 5 plus negative 2 is 0. And I can simplify that more because I know that anything to the 0 power is 1. Number 3, I have everything in the parentheses that goes to the second power outside the parentheses. And when I have a power raised to another power, the base stays the same, and I multiply the two exponents. So I get 3 to the negative 8th, and I never leave my answer with a negative exponent. That would be 1 over 3 to the 8th. Okay. Now I could also go one more step, figure out what 3 to the 8th is, but I'm just going to leave it like that for now. Alright, next one, same idea. Everything inside these parentheses is going to go to the third power. This 2 is not inside, so the 2 stays there. And then x to the negative second raised to the third is x to the negative 6, because I'm multiplying the exponents. Y to the fourth raised to the third is y to the 12th, because I'm multiplying the exponents. I never leave that negative exponent in a final answer. So imagine this is all over 1. The 2 stays in the numerator. The x to the negative 6 goes down to the denominator and becomes x to the positive 6th. And y to the 12th stays in the numerator because that's a positive. And then that's my answer. Alright, number 5. Now we're talking about quotient rules. Same base and dividing. The base stays the same, and I subtract the exponents. 10 minus 4 is 6. Same thing for problem 6. Same base. Subtract the exponents. Negative 2 minus 3 is negative 5. And I would never leave a negative exponent in my answer, so it's 1 over 2 to the positive 5th. And that'll be easy enough. 2 to the 5th is 32. 1 over 32. Alright, number 7. I have everything in the parentheses raised to the third power. So x is going to the third power. And y to the second is going to the third power. And that's as far as I can go. I'm not going to subtract the exponents because the bases are different. And number 8. Everything in the parentheses is going to go to the third power. So the 2 is going to go to the third power. 8 to the 4th is going to go to the third power. 8 to the 12th. The 3 in the denominator is going to go to the third power. And the b squared is going to go to the third power. That will be b to the 6th. I can simplify that a little bit more because I can actually figure out 2 to the 3rd, it's 8. 8 to the 12th. 3 to the 3rd is 27. B to the 6th. 8 over 27 can't be simplified, so that's as far as I can go. Alright, number 9. Now, using our quotient rule, x's, I'm just looking at these right now. Negative 5 minus 4 is negative 9. Just look at the y's now. 6 minus negative 2 is 8. And now just look at the z's. That's z to the first power, z to the first, or 1 minus 4, z to the negative third. All that's over 1. Get rid of my negative exponents. X to the negative 9th will come into the denominator, be x to the positive 9th. Y to the 8th, I can just stay in the numerator because it's positive, I don't have to move it. And then z to the negative third goes into the denominator, is z to the positive third. Yep. No big deal. Just like the other problem, just has a few more factors, a few more variables here. All right, number 10. First, I'm going to look at this 12 over 20 as a fraction, and I'm going to simplify it. So what, 4 goes into 12 3 times, 4 goes into 25 times. All right, now I'm going to deal with the a, and a negative 3 minus negative 2 is negative 1. I'll look at the b's. 4 minus 6 is negative 2. All right, the 3 can stay. A to the negative, and the 5 can stay also, sorry. The a to the negative first will go down into the denominator and be a, or a to the positive first. B to the negative second will come into the denominator, and b to the positive second. And then that's it. That's as far as I can go. Right, we get a few more. All right, 11. Everything in that numerator, since it's in parentheses, is going to the second power. The 3 has to go to the second power. The x squared has to go to the second power. And the y to the negative third goes to the second power. Denominator, just leave it the same. All right, now, let's see, the 3 squared is 9. We'll leave everything else the same way. Let me just take care of that first and take a look. Denominator, just keep it the same for now. All right, now, I'm going to look at this fraction. I can simplify that fraction. 3 goes into 9 3 times, 3 goes into 6 twice. Now look at the x's. X, 4 minus negative 1 would be 5. And I look at the y's. Remember, that's a y to the first there. Negative 6 minus 1 is negative 7. 3 is okay. The x to the fifth can stay because that's a positive exponent. The 2 can stay in the denominator. But the y to the negative 7th will come into the denominator as y to the positive 7th. And that would be my final answer. All right. Let's see. Everything in the numerator in the parentheses goes to the fifth power. So that means the 4 that was outside the parentheses does not. It just stays 4. A to the negative first goes to the fifth power. A to the negative fifth. B to the third goes to the fifth power. B to the 15th. In the denominator, everything in the parentheses goes to the 0 power. The negative 2 stays negative 2. Well, everything in here, since it's going to the 0 power, that just equals 1. Anything to the 0 power is 1. All right, let's simplify. We have a 4 over a negative 2. That would be negative 2, or negative 2 over 1, but I don't need the 1 there right now. A to the negative fifth will bring down into the denominator, make it a to the positive fifth, and b to the 15th can stay in the numerator. That's a positive exponent. And then that's it. That's as simplified as I need to go, or as I can go. All right, last one. This was the most complicated of all these. All right, so we have everything in the parentheses here going to the negative second. We have 4 to the negative second. We have x to the third to the negative second. Denominator, everything in the parentheses is going to the negative third. So we have 2 to the negative third. We have y to the negative first to the negative third, which would be y to the third. All right, and now over here, everything in the parentheses is going to the negative fourth. So that means this 3 is not, this stays 3. And then that y to the negative second to the negative fourth would be the positive 8. And then denominator x to the 7th just stays. All right, we got a lot going on here. Let's see if we can clean this up a little bit. If I'm looking just over here, that 4 to the negative second, I could bring down into the denominator and make it 4 to the positive second. X to the negative 6, I bring it down, make it x to the positive 6th. 2 to the negative third, I can bring it up in the numerator, make it 2 to the third. And then that y to the third can stay in the denominator. That's a positive 3, so it just stays. And over here, we just have 3y to the 8th and x to the 7th. Nothing to do there yet. Let's come over here. 2 to the third is 8. 4 squared is 16. And then just x to the 6th, y to the third. That's there. And then over here, just keep it 3y to the 8th for now, x to the 7th. Alright, we can multiply across. So we're going to do 8 times 3, 24. And then we have y to the 8th. Down here we have 16 times, there would be a 1 in front of there, 16. We have x to the 6th times x to the 7th, which would be x to the 13th. And then we have just the y to the 3rd. We're getting there. Alright, let's simplify 24 over 16. Let's see, 8 goes into 24 3 times, into 16 twice. We have this x to the 13th in the denominator, so that can just stay. And then up here we have the y's, the y to the 8th minus y to the 3rd, so y to the 5th, or 8 minus 3 is 5, so y to the 5th. And that's everything, fully simplified. So that one took a lot of steps, but no big deal. Alright, so we're going to use all our exponent rules. We're going to use our knowledge of 0 as an exponent, use our knowledge of negative exponents, and we're going to simplify all these, even ones like problem 13 that are fairly complicated and you're using a lot of the rules. Alright, good luck, guys.